Hi guys, welcome back to my new video. As you all know that myself Rakshidi, currently pursuing my BE degree in Sri Venkateswara College of Engineering in the Department of E&C. Today I am here to discuss a subject, Mathematics for Triple History, and the topic is application of volume in the numerical method. So I hope you guys will like the video. So without wasting the time, let's get into the video. The first part, as usual in the video introduction, the introduction to numerical methods for a volume calculation. Numerical methods play a crucial role in accurately estimating the volume of a complex shapes and the objects. These mathematical techniques allow us to precise calculate the volumes when the analytical solutions are not feasible and enabling a more accurate measurements and optimize it in design process. So let us know the importance of accurate volume calculation. The first one is engineering design. Precise volume calculations are essential for designing structures, vessels, and the components to meet a specific capacity and performance requirements. The second one is scientific research. Accurate volume data is critical for researchers studying a natural phenomena such as fluid dynamics, geological formations, and biological systems. The third one is process optimization. Optimizing volume dependent process like material storage, transport, and manufacturing requires reliable and numerical volume estimates. Let us know the fundamental concepts of volume. The first funda is definition of volume. Volume is the three-dimensional shape occupied by an object or a region, typically measured in units such as cubic meters or liters. The second funda is volume formula. Analytical volume calculation rely on geometric formulas for a regular shapes such as rectangles, cylinders, and shapes. The third funda is irregular shapes. Numerical methods are essential for calculating the volume of objects with the complex, irregular shapes that cannot be solved analytically. So, let us know the techniques for volume estimation. The first technique is finite difference method. Divides the object into a grid of small elements and applies numerical approximation to calculate the volume. The second technique is Monte Carlo simulation. Generate a random samples within the objects and uses statistical methods to estimate the volume. The third technique is finite element method. Discretize the object into a mesh of a smaller elements and use a variational principles to estimate the volume. These are the techniques used to determine the volume. Let us know the finite difference method for volume calculation. The first one is grid-based approach. The finite difference method divides the object into a grid of a small elements and applies a numerical approximation to calculate the volume of each element. The second one is accuracy and convergence. The accuracy of the finite difference method depends on the grid solution and the solution converges as the grid is refined. The third one is computational efficiency. The method is computationally efficient, making it suitable for large scale volume calculation, especially in the object can be easily discretized. Let us know the finite element method for a volume determination. The first method is mesh generation. The object is discretized into a mesh of small elements such as irregular triangles or a tetrahedral to approximate the geometry. The second method is shape function integration. The volume of each element is calculated by integrating a shape functions over the element's domain. The third method is global volume summation. The total volume is obtained by summing the volumes of all the individual elements in the mesh. These are the methods to determine the volume. So let us know the comparison of numerical techniques. The first one is finite difference. When it comes to the accuracy, it has a high for a regular shapes. When it comes to the complexity, it's relatively low. Its application in large scale volume calculation and simulation. The second one is finite element method. When it comes to the accuracy, high for irregular shapes, moderate to high in the complexity, and it used in the applications like complex geometries and structural analysis. The third one is Monte Carlo simulation, suitable for complex shapes in accuracy, high in complexity, and it is used in the applications like stochastic problems and optimization. So let us know the practical applications and case studies. The first thing when we came to my mind is gas. The gas is usually measured in terms of volumes. The first application is oil and gas. Accurate volume calculation are crucial for the design and the optimization of storage tanks, pipelines, and the processing facilities. The second application is biomedical engineering. Numerical methods are used to estimate the volumes of organs, tumors, and the other anatomical structures from medical imaging data. The third application is construction and civil engineering. Volume calculations are essential for estimating the capacity of structures, planning, excavation, and the field operation, and the optimizing the material usage.